Okay, everybody, we're going to take a look at these linear modeling examples here. But first, let's kind of review our average rate of change. So if we have a function right here, negative f of x is negative 2x squared plus 10, we're looking over the domain 0 to 5 here. So I'm just going to substitute that into my calculator and then go right to the table and then just check out our points that we have here. So if I've got x and then f of x, all right, I'm looking at 0 and then I'm looking to 5, so the point 0 would give me an output of 10. And then you see if you go down to 5, you're going to get an output of negative 40. So then if we want to go ahead and find the average rate of change, remember the change in the y over the change in the x. Okay, so I've got negative 40 minus 10, and then 5 minus 0. So we're going to get negative 50 divided by 5 gives us an average rate of change of negative 10. Okay, so that's the foundation, that's the baseline of the linear functions. Okay, but now let's take a look at some of these models here. Okay, the first one we're going to look at here is the average temperature of the planet is expected to rise at an average rate of 0.04 degrees Celsius due to global warming. Okay, so this is just a model that was developed where x represents the number of years since the year 2000. Right, so if I substitute in 0, that means the year 2000, and we're starting at a value of 14.71. Let's go ahead and take a look at this in our calculator. So I've got 14.71 plus the rate of change would be 0.04 degrees in each year. Okay, so now you can go ahead and take a look at this in our calculator, or we can substitute the values in if you want by hand. Right, so what I'm going to do is what would the value be in the year 100? Because we're using 100 because x is 100 years after the year 2000. So if I go ahead and substitute in, if I want to look at my table set button, so if we click the table set button, and if I want my table to start at 100, then if you click the table button, it'll take you right there. Right? It'll take you right to 100, and you're going to see what would the temperature be. The temperature would be 18.71 degrees Celsius. And how do we find that? Well, we just basically substituted in 100 and found our answer. Okay, and then what does this model project the average global temperature to be in the year 2200? Okay, so now we're going to say, well, let's check 200, right? Because it's 200 years after the year 2000. So we would say our Celsius is equal to 14.71 plus 0.04 times 200 years later. So you could, if you wanted to in your calculator, you can kind of just scroll down, or you can use your table start to enter that in. But then if we look at the year 200, okay, we've got C is equal to a value of 22.71 degrees Celsius. Okay, right. So now you're looking at algebraically determine when the number of years it would take for it to reach 20 years. Algebraically, we know that y value is going to be 20 is equal to 14.71 plus 0.04x. Now we're looking for the x. Okay, so what we do here is we would subtract from both sides 14.71 minus 14.71. So I've got 20 degrees minus 14.71. I'll go ahead and hit enter. I've got 5.29 is equal to 0.04x. And again, one more step here, just divide by 0.04. Divide by 0.04. On a calculator, divide by 0.04. And you're going to see that it would take 132 and a half and 0.25. So rounded to the nearest year would take 132 years to reach that temperature. Okay? All right. So what we're going to do here is take a sketch of the graph, and I wanted to show you how to use this point. And we're going to start by saying, hey, look, we're going to put 14.71 here. And we're going to make this run from 0 to 200. That's going to be the sketch of our graph here. Okay, so how you do that is the window button on your calculator. If I go to the window, and now I'm going to say, let's make this run from 0 to 200. And I'm going to put a mark for every 50 years. And then the minimum is 0, and we don't really know what the maximum is going to be. We don't know what the temperature is going to be, right? But you can kind of tell by these answers right here, 18.71, 22.79. Both of those answers will give us a value of, I don't know, let's say 50 just to play it safe, right? So if I go ahead and hit the graph button, you can see here that there it starts. And it's just going to go up right there. And you can see it's a linear function, right? Okay, we've labeled our starting value, which is 14.71, which is the y-intercept. Okay, and then one additional point, you can pick any point you want along here. You can slide along, right? Or you can go into your calculator and your table and find value. Okay, that's probably a little bit easier way to look at it. So if I look at the table here, I want to say, well, what's it going to be at 150 years? The temperature is going to be 20.71. So you'd say at 100, let's get this a little bit more, or 150, sorry, 150 years, the temperature will be 20.71. All right, so that's how you're going to use this linear function, okay? All right, now working on to what happens if we have two graphs, and this is really a system. We're not going to be working too much into systems here, but now what we want to do here is set up our calculator from 0 to 500. And then we're going to have two functions here. We're going to have this one, and then we're going to have this one. So we're going to have two functions on here. Okay, and what these are they're selling widgets, and it costs 26 cents every time you sell a widget, right? Okay, so you can see down here, that's where it's 26 cents to sell a widget here. Okay, so if we're going to go ahead and take a look at this, we go into your y equals. All right, we're going to clear this out, and I want to get 0.18, which will be 18 cents a widget, plus the initial charge of 20.64. And then I'm going to look at the other one and say, well, this is going to be just straight 26 cents per widget, or 26 cents x, okay? And what we're going to do here is if we go to our window now we're going to run from 0 to 500, right? We're going to say, well, let's put a mark at every 100 feet, or 100 widgets sold. And now we're going to say our y value is going to be 0, and then we don't really know, so 50 is probably a good amount because look, you're starting at 20 right here. And I'm going ahead and hit the graph, and you can see that my y is too low. So if I go back here, I'm going to go back to my window, and then my y max being 50 is going to be a little bit too low. So I'm going to put that up to 200 now and see what that looks like. So if I go ahead and hit the graph, now you can see a little bit clearer where we have. Now both of these functions, we've got this function that's going up like this, and we've got this function which is going up like that. And you're going to see they're both going to intersect at a point, okay? And that point of intersection right here is the point, the x value would be at 258. The cost would be $67.08. So that's how you'd intersect, right? Okay? So if profit is defined as the revenue minus the cost, create an equation in terms of P for the profit P, okay? So the way you're going to look at this here is you know that the cost is right here, the C, and then the revenue is the R, okay? So you can think about it really as the cost, the profit, is really equal to the revenue minus the cost. Okay, so if I were going to make that into one equation, I would say the profit is equal to the revenue, which is 0.26 W, and then minus the cost, so minus 0.18 W plus 20.64 So if we're subtracting both of those values, we would get P is equal to 0.08 W minus 20.64. Okay, so you're just combining two linear functions. Okay, what is the minimum number of widgets that must be sold in order for the profit to reach at least $40? So now you're going to say, I want to make $40. So now you've got this equation combined right here. And then you're just going to have to solve for it. So if I add to both sides, 20.64, 20.64, I'm going to get 60.64 is equal to 0.08 W, and then divide by 0.08 on both sides, 0.08 on both sides, and I'll check to see what that is. So 60.64 divided by 0.08, I'm going to get this, 758 widgets to be sold. So once they reach 758 widgets, you know you're going to be making a profit of $40. Okay, so this is a way to kind of combine two of your functions, right? We've got a cost is equal to 0.18 W plus 20.64. We know that we're starting at 20.64. And then right here, the revenue is equal to 0.26 W, because every time we sell a widget, you're going to make 26 cents. Okay, so that's the way to combine two linear functions. And there's much more of a mathematical approach to looking at finance. Okay, and then that last little example is just a straightforward linear function, right? We know that Rashawn wants to ride his bicycle 26 miles this week. Okay, we know he's already ridden 8 miles, so there's already 8 miles under there. And then if he rides for 3 more days, how much would we have to average? Okay, so if you know that he's already ridden 8 miles, we're going to start with 8, right? And then he needs to ride 3 more days. So 26 is going to be our value. So how would we find out how many he would have to ride? And you can see here, if I divide by 3, you're going to get x is equal to 6. So we'd have to ride 6 miles in a day. Okay, so this is a very, very, very straightforward linear equation, a linear relationship, and it's all sort of related. Okay, all right. Hope all is well. Good luck. Reach out to office hours if you need anything.